Hi everyone, this is 5.6, Proving Triangles Similar by AA. A lot of what we're going to do in the next two lessons is going to be pretty familiar since we're just coming off of the congruence unit. So hopefully it won't be super difficult, and it's really going to be a lot less involved too. So just two lessons, first one beginning today. So first one we have, it's a shortcut. It is a shortcut to determining if two triangles are similar to one another. So AA stands for angle, angle. And what it says is that if two angles of one triangle are congruent to two angles of another, then those triangles are automatically similar. So it's pretty nifty. Usually it's pretty easy to find two congruent angles in a triangle, and if you can come up with that, then your triangles are automatically similar. You don't have to go through and check the scale factor on all three sides and make sure it works out. So I just want to illustrate kind of why this works. So this next part, you don't need to write this down at all. Just kind of watch. So right now what we have are two congruent triangles. They're exactly the same. They're 45, 45, 90 triangles. We have sides of 4, 4, and 5.6. And what I'm going to do is I'm going to make the triangle on the right bigger. So I'm just going to pull this out so that it gets bigger. I'm going to scroll down a little bit here so we can see. Okay, so what you'll notice is that the angles didn't change at all. So if we're using this angle thing, and we're given all three angles in this case, but say that we just know the 45 and the 90 and the 45 and the 90. Well, one thing is that we would automatically know that the third angle is 45 because we know that three angles of a triangle always have to add up to 180. Or we could use that third angle theorem that says if you already know two, if two are the same in each triangle, then the third one is also the same. So that's why we only need two angles, basically because of the third angle theorem. But either way, what I want to do here is just check and make sure that the sides stayed proportionate. So these numbers are kind of goofy. They're not nice, easy numbers, but we have calculators, so we can totally check. And you don't even need to check. I'm going to do it for us. So what I'm going to do is I'm going to check. I'm going to divide from right to left. So I'm going to do 8.7 divided by 5.6. And I'll do that in a calculator in just a second. And then I'm going to check the other side. I'm going to do 6.2 and 4. And I'm going to divide backwards. 6.2 divided by 4. Just went into Desmos and typed those in, 8.7 divided by 5.6, 6.2 divided by 4. And you'll notice there's a little bit of a rounding error. Those sides probably weren't exactly 8.7 and 5.6. The computer probably just rounded for us a little bit. But you can see that we're super duper close. We get 1.55 and 1.55 basically with a little bit of rounding there. So it is true that when the triangle became bigger, the angles didn't change at all and the sides remained proportionate. So that's why it works. It's as long as your angles are staying the same, the sides are going to stretch out at the exact same pace. Okay, we're just going to do three examples. I'm going to go in order from like easy to medium to harder. So this would be considered a pretty easy problem right here. So we have these two triangles, and we're going to decide if they are similar or not using angle, angle. So right off a first glance, I can see that we have a 90-degree angle and a 90-degree angle. So one of our angles is good. So basically right now we have angle. We need angle, angle. So if we look, it looks like we have a 48-degree angle and a 42-degree angle. They're obviously not the same, but we're not done yet. We can't just say, no, they're not the same, so not similar. We need to go and find the third angle in really just one of our triangles. Okay, so to do that, easiest thing we can do is just start with 180 degrees, take away the 90 that we already have, take away the 48 that we already have, and I believe when we do that, we're going to end up with 42. So that angle F is actually 42 degrees. Okay, so if we're being like really good about showing our work here and really trying to prove that these two things are similar, these two triangles are similar, we really should do this. We should tell the whole world that angle H is congruent to angle J. So that's one of our angles. And then we also should say that angle F is congruent to angle K. Okay, so now we can say by angle, angle, we can now say that these two triangles are similar. So let's go HGF is similar to J, which way would we want to go here? We want to go JLK. Okay, so knowing absolutely nothing about the sides, nothing about any of the proportions, because we have this trick, angle, angle, or this shortcut, we know that those two triangles are similar. All right, moving on to a little bit tougher of an example, we have, I'll call this a medium level, and I want to see if these two triangles are similar. So I am looking at this triangle right here, which I'll kind of make red, and then this triangle right here, which I will make blue. I want to know if those are similar or not. So what I can do, because I have a smartboard, is I can separate them so we can see them a little bit easier. Okay, so do they look similar? They certainly do look like they're the same size or same shape, but different sizes. But we don't know for sure yet. So what we do know is that this little blue one has a 65-degree angle, and we know this red one has a 65-degree angle up in that upper left-hand corner. Okay, the trick on this one is, where is that second angle? Is there a second angle? Well, if you notice, both of those triangles come together at angle C. They both share angle C. I'll pull them apart one more time. Blue one has angle C, red one has angle C. So we don't know what the measure of it is, but we know that angle C is congruent to angle C on both triangles. And that seems kind of weird, but that's true. That's actually like a reflexive property with angles, okay? I like to just say it's a shared angle. Okay, they share that angle. They both have that angle, both triangles. Okay, and then the other thing we know, and we have to be a little bit more careful here, because there's a lot going on at B here. So we can't just call it angle B. We have to trace it. So if we're talking about the blue triangle, we need to go C, B, D. So angle C, B, D is congruent to angle A. Okay, they're both 65 degrees. And we can just call that angle A because there's nothing else going on at angle A. There's too many things going on at point B to call it just B. Okay, so at that point, we're ready to write our similarity statement. So we can say by angle, angle, triangle, CBD is similar to triangle. We want to go in that same order. So I went around this way. I want to do the same thing. C, A, E. And we are done with that one. All right, and one more. This is kind of the harder example because right now nothing is marked for us. We don't have a single angle on there. So we need to do a little bit of work. So first thing I would do is kind of outline the two triangles that we're looking at. So I'll make, once again, a red one and a blue one. And right away, hopefully you're noticing that both of those triangles go through angle N. So that's the first thing that we can say. Angle N is congruent to angle N. And I marked it on there, and you can mark it on yours as well. Okay, now the second question is, what other angles do we know and why? Okay, well, I do notice that we have parallel lines. These little arrows right here tell us that we have parallel lines. Okay, so in this case, we don't really want to look for alternate interior angles. We're not really going to come up with much if we try that. But what I do notice is I kind of notice the letter F. See how right here you can kind of see the letter F? Make it green, like that. And remember the armpits of the letter F? So there's an armpit and there's an armpit. Those are called corresponding angles. And if you have parallel lines, your corresponding angles are going to be congruent. Okay, so that's going to give us enough information to say that the two triangles are similar to one another. So it's going to be a little bit of work to write this out. We're going to go angle NMP. So this angle here, NMP, is congruent to angle. Couple different ways we can name it. I'm going to go NLQ. You certainly wouldn't have to do it that way, but that's how I'll do it. NLQ. Okay, so this guy was a shared angle. And then this guy is corresponding angles. Are congruent. Okay, I kind of like these. They're kind of a puzzle. You're just looking to find two angles that you can prove are congruent, and if you can, then you automatically know that your two triangles are similar. So once again, by angle, angle, triangle. We'll go with the little one first. I'm going to go NPM is similar to triangle NQL. That would get our big one, NQL. Okay, or there's many different ways to write it. We could have written it kind of the same way that we did this guy here too. Doesn't really matter as long as your letters are in the right spot. So sorry that video got a little bit long, but hopefully that makes sense. If not, certainly let me know and I can sit down with you and try to clear anything up for you. Okay. In summary, use the theorems and properties we've learned this year to find at least two congruent angles. Then you can prove the triangles are similar.